Okay, so the last thing we did was look at the start of Newton's second law. What would happen if there was an unbalanced or overall force acting in a situation in an object? So you can write that out in words, that if an unbalanced force is acting on the object, then the object's going to accelerate in the direction of that force, and the size of the acceleration is proportional to the force and inversely proportional to the object's mass. So in other words, if you increase the force by 10 times, the acceleration will go up by 10 times because they are proportional. And that's what that symbol like that is indicating, the alpha. 10 times the force gives you 10 times the acceleration. Right? So that's directly proportional. In terms of inversely proportional, which you can write like this, the mass is inversely proportional to the acceleration, which means if you get more mass, you're going to get less acceleration. So in this case, 10 times the mass, it's a lot more inertia, it's a lot harder to accelerate, so you'll actually get 1/10 of the acceleration if you put that in there, you get 1/10. So putting those two ideas together, you get it written like that in a formula form. Okay? And you can answer questions about these as well with some numbers. So they do ask you, here we've got a car that's got an engine force of 4,000 newtons going to the right, so it looks like this, 4,000. And it's also got a friction force total of 1,000 to the left. So that's going to pull the car backwards there. I haven't drawn those to the right length there. This one should be shorter than that one. So to work out the acceleration of a car that's got a mass of about 1,500 kilos, we would use that second law. Okay? The question is, which force do you put in? Do you put the 4,000 newtons of engine force in, or the 1,000 newton force? What does this force mean? Well, it actually means the net force, or the total force, or the unbalanced force. So we need to work out what the unbalanced force is over there. So it's 4,000 right, and you've got to subtract that 1,000 going backwards against it. So that's going to be 3,000 to the right. So that's the sort of thing you need to keep in mind. The overall force is to the right here, and it's got a mass of 1,500. If you check that on a calculator, it's 2 metres per second per second. And it's going to go in the direction of the force just out of interest. It's going to go the same way. Okay? So that's the second law there. That was the last one we did. In terms of the third law, okay? A lot of people just remember it as action equals reaction. There's an action force on one object, you'll end up with a reaction force on the other object. And it's always the same. So the other way you can sort of think of it is, if an object A exerts a force on another object B, then the object B, the second object, will exert an equal and opposite force back on the first one. Or you can think of it like that. They always occur in equal and opposite pairs on different objects. Okay? So a good example of that would be a hammer and a nail. If the nail pushes the hammer, if the hammer pushes the nail down with a force of the hammer on the nail of say 10 newtons, that's going to force the nail into the wood because it accelerates the nail because it's an unbalanced force. That's the second law. But this law here says it should be an equal and opposite force pushing back up on the hammer. So the nail should have a force on the hammer of 10 newtons in the opposite direction. Now that also does something to the hammer because it's an unbalanced force on the hammer. It should slow it down and stop it. Okay? So it should slow it down and stop it. So that's just one example of a pair there that's actually going on. If you're swimming in the water and you're pushing water backwards, you'll get an equal force from the water pushing you forwards. Okay? So there's that one there as well. Other ones you could consider is a car windscreen hitting a little fly or a bug at high speed, so 100 kilometres an hour. When it hits that bug, are the forces the same between the bug and the car? Now some people say no, they reckon the bugs experience more force. But the law says they're the same. So why is the effect different if they are the same force? Well, it's because the car's got a big mass. So for the same force exerted between the bug and the car, it's not going to have much acceleration, is it? Because it's proportional to mass. The mass is big, that's really tiny. But for the bug's a little tiny mass, so the acceleration is much bigger. And enough to actually obviously squash the bug completely into liquid virtually. Okay? The deceleration of the bug is extremely high for the same force. The deceleration of the car for the same force is negligible, you won't even notice it. But the forces are the same. If you step out of a boat like that, okay, there should be an equal force back on the boat. You push back off the boat to go in or off, the boat will be pushed backwards with the same size force. Okay? So just bear those things in mind. There's a demonstration you can do to actually show that with a couple of carts there, which will exert equal forces on each other. Okay? If you load them up like this, and you put them with the same mass to start with like that, and let them go, okay? And just knock them off there. The spring-loaded one here, so cart A will push cart B forwards, but cart B is also pushed backwards by the second cart. So they have an equal force on each other, but they also have equal accelerations in this case because the masses are the same. If you go and load up another cart now, like this one here, and actually load this up with something, say 5 kilos then, so we actually increase this mass by a fair bit. It's probably close to 8 times now. When you do the spring load this time, and I'll just put that in the right position there, when you put the spring load this time, the recoil is a lot smaller on the more massive cart. Are the forces still the same? Yes, they are. But the effect is different because of the difference in mass. The second law says more mass, less acceleration, while the third law is saying equal forces, opposite directions. Okay? So just bear that in mind there.